Good morning, my dear friends. I hope you all are doing great. Dear friends, today we'll be talking about a new chapter called as equilibrium. Before we start this chapter, many of the students do have many doubts regarding log and anti-log functions, my dear friends. And what is the application of log and anti-log functions in our chemistry, my dear friends? Let's have a look. If you talk of a chapter called as thermodynamics, or you may have a chapter which we are starting today is equilibrium. These are few first chapters, my dear friends. And then you have chemical kinetics, and then you have electrochemistry. So they are few second chapters. Now, if you look at these chapters, my dear friends, in these chapters you have to use log and anti-log functions. And these log and anti-log functions are very much important for your theory exams as well as for your NEET and JEE exams, my dear friends. So before we start this particular chapter, equilibrium, let us get to know about log and anti-log functions, so that whatever the problems will come in this particular chapter, you should be easily able to solve them. So let me clarify your doubts today regarding log and anti-log functions, my dear friends. Please be very much, attentive throughout this particular class. So, my dear friends, I will write down here log functions. Correct. Now, my dear friends, what kind of log functions you have to know? About anti-log we will discuss later, but first of all we will talk about log functions. In chemistry, you have to deal with only two types of log functions. One is basically yours common logarithmic function, and another one is natural logarithmic function. So now you'll be thinking that what is this common logarithmic function, my dear friends? I want to tell you the log function with base 10. The log function with base 10 is known as common logarithmic function, my dear friends. And now what is this, my dear friends? The log function with base e is known as natural log function, my dear friends. Now you have two types of log functions, common log function and natural log function. Here the log function with base 10. This is the log function with base e. Now you will be thinking, my dear friends, what is this all about? Let me show you the expressions here, my dear friends. I will write down here log, and what should be the base of the log? The base of the log should be 10. So this is the base of the log. Now when I talk about the natural logarithmic function, my dear friends, the log function with base e, it should have to be there. So here natural log is represented by ln. You can represent it by ln, and then you can write down it's equal to log to the base e. So this is your natural log function, and this is your common logarithmic function, my dear friends. So how to use them to solve the problems in chemistry and all, we will get to know about that. Please make note of this. Dear friends, let us elaborate these two concepts here, my dear friends. Let us take on the first one, common log function. And we know, my dear friends, in common log function, we have log with base 10. Yes? So, let me find out the log for some number. Okay? Let us suppose I want to find out the log x. And let us suppose that log x is equal to y for time being. And remember, I am finding out actually log x. Log x is equal to y. And we know that we are using the common log function where the base is 10. Okay, my dear friends? I can write down if log x is equal to y, okay, then please try to remember, then 10 to the power y. Try to understand, my dear friends. This is the base here. Remember, this is the base of common log function. This is the base. So take this base 10. 10 raised power y. 10 raised to y is equal to x. Please remember this particular expression for the common log function. So I took log x is equal to y. Okay, then 10 to the power y. 10 is nothing but the base. 10 to the power y is equal to x. Let me further simplify it for you people. In exams, my dear friends, if it comes like this, if log, let us suppose, 1 is here, you want to find out log 1, okay? What is this log 1 equal to, my dear friends? We know that log 1 is equal to 0. They won't mention, remember, in books they don't mention this 10. You have to understand, my dear friends, they will tell log 1 is equal to 0. But you should remember that it's a common log function and obviously the base will be 10 only here. Yes? So what is important, my dear friends? This y is nothing but it is here 0. What is the base here? 10. Here is also the base 10. And what is x? That is 1. So how can I write it down? Then 10 to the power 0. 10 to the power 0 is equal to 1. That 0 is nothing but 0 is the y and this 1 is nothing but it is x. So I hope, my dear friends, you are understanding. Okay, look here. If log, okay, 2 is equal to 0.3010, my dear friends. Log 2 is equal to 0.3010, correct? What is the base here? 10. So how to simplify it here? Then, my dear friends, 10 to the power 0.3010. 0.3010 is equal to, how much is that? 2. So this will be equal to 2. So I hope you have understood. This 10, remember, this 10 will not be mentioned in the questions. You have to understand that it's a common log function. They will tell you log 10 is equal to 1. Okay? So you should remember that there is a base and that base is actually 10, my dear friends. Please remember this thing. Okay, have a look here. If log 10 is equal to 1, my dear friends, we know that log 10 is equal to 1. What is the base? Remember that base is here 10. So 10 to the power 1. Then 10 to the power 1 is equal to 10. Yes. I hope you have understood this, my dear friends. Let us go for now, after this, natural log function. Same expression will be there only, but the only thing is that here the base is basically 10. Here I have to replace the base 10 by e. That is the only thing which I have to do, my dear friends. Please make note of this. Dear friends, now let us talk about the natural log function, my dear friends. Natural log function. Before we start the natural log function, you must know about one thing here, that is base e. Here in the common log function we have base 10, so no problem. But here we have base e. What is this e all about? Let's learn first. This e is known as Euler's base. And what is the value of this e? You must know it's equal to 2.718. Okay, you can use directly 2.7, that's enough. Okay, Now after that, let us come back to the natural log. Okay. In natural log we have ln, okay, which is equal to log with base e, or log to the base e. So this is our natural log. This natural log can be written as log with base e. Okay. If I write down log with base 10, it will become a common log. But it's a log with base e, and that e is nothing but Euler's base. The value of this e is 2.718. So it can be also written as log 2.7. 2.7 means that's Euler's base. Okay. Now let us, if my dear friends, if log, what is the base here? E. Log with base e, which is a natural log. Okay. Let me find out the natural log of some number, let us suppose. Let me find out for a, log a. But remember, this is a natural log because base is e, is equal to, let us suppose, b. So what will be the expression, my dear friends? We have already learned, take the base is e here. So e to the power b is equal to a. So that is the expression. Okay. Now let us simplify it further. If log with base e, okay, and we know that base e is 2.7. So in place of e we can write down 2.7 also. So let me write down here, we will find it for 7.29. Okay. It's equal to 2. So what is my expression? Then my expression is e to the power, this is the base, take the base here, and take this as power, e to the power 2 is equal to 7.29. And we know that e value, how much is e value, my dear friends? 2.7, or here you can see 2.7 e value. So it will be also equal to 2.7 raised power 2 is equal to 7.29. So I hope you have understood that what I have done with the common log and with the natural log, my dear friends. In common log, base is 10, and in the natural log, the base is e, and that is Euler's base. Its value is 2.7. Now after this we will study that how we can relate the common log and the natural log. So relation, how common log is related to the natural log. How we can simply write down relation between natural log and common log. Okay, so let us see. So what is the relationship between them? Let us take on the natural log. ln is our natural log. I am not going in detail, I am showing you the techniques how you can find out the things. ln is equal to log with base e. This is your natural log, my dear friends. Both are your natural log only. Okay. Now how the natural log is related to the common log? It's equal to 2.303 log with base 10. If you don't mention here 10, it's understood. Everybody will understand that when nothing is mentioned here, it is 10 only, because we are using common log and the natural log. Okay. But for natural log, if you are maintaining log here, then you have to mention the base e. For common log, no need to mention anything. It's understood that 10 is there. So this is how they are related. The natural log ln is equal to log with base e. Okay. That's equal to 2.303 log with base 10. So in chemistry, when you are solving certain problems and all, there they will give you mostly the natural log, and then you can convert the natural log into the common log. So your natural log is ln. So if ln is given, let us suppose, and we know that ln is equal to 2.303 log with base 10. Or in place of ln, they can also mention, let us suppose they have mentioned log with base e. It's the same thing, 2.303 log with base 10. Because this and this both are same. That is nothing but it's your natural log only, my dear friends. I hope you have understood that how to convert the natural log expression into the common logarithmic expression, my dear friends. Please make note of this. Dear friends, let us calculate the log values from 1 to 10 by using common log function. Have a look here. We have log 1 here. Log 1 is equal to 0, my dear friends. Okay? What is the base for the common log? Everybody knows it is 10. You need not mention it, just see. What was our expression, my dear friends, if you remember? If log 1 is equal to 0, then 10 raised power 0 is equal to 1, then 10 raised power 0 is equal to 1. So obviously 10 to the power 0 is equal to 1 only. That was my expression. Okay? Now have a look here. If log 2 is equal to 0.3010, this is the expression for log 2. What is the base here? Base is here 10. Then what happens, my dear friends? Then 10 to the power 10 is the base. 10 to the power 0.3010 is equal to 2. This is the expression. So remember, this is the base here. This is the base. So these things we have already done. So let us come back to our topic. Let us start, my dear friends. Remember, the base is 10 only. So I am not going to mention the base 10. So log 1 is equal to 0. Correct? What is log 2 equal to? Log 2 is equal to 0.3010. Correct? Now, what is log 3 equal to? Log 3 is equal to 0.4771, my dear friends. Okay? Now, what about the log 4? What is log 4 equal to? You may be thinking that log 1 is 0. Everybody can remember this thing. Log 2 is 0.3. Okay, it's also easier. Log 3 you have to remember. So remember log 3. Log 3 is 0.4771. So 0.4771. Log 1 is 0. Everybody knows about it. Log 2 is equal to 0.3010. It's easy. Now you may be thinking now that if we are supposed to remember all these values, then what is the use? Let me tell you, my dear friends, have a look here. Please remember this thing first of all. If I have a log, okay, a to the power b. Log a to the power b is equal to, take this b here. So it will become b log a. So that is the expression, my dear friends. So remember these key points. So log a to the power b is equal to b log a. Now look here. If I want to find out log 4, I can write down it as log 2 to the power 2. Yes? So obviously this expression will become exactly like what? This particular expression, if you remember. So it will become exactly like this. It will become log a to the power b, that is b log a. So my dear friends, now this is log a to the power b. So I will be getting here, take this 2 here, so it will become 2 log 2. Correct? Then 2 into, you are knowing the value of log 2 and log 3 already. So what is log 2 equal to, man? 0.3010. So at least you remember log 2 and log 3 value, you remember, my dear friends. Okay? So obviously you will be getting here log 2 is equal to 0.3010, my dear friends. So this will be equal to 0.206. That is 0.6020 is log 4. So log 4 is equal to 0.6020, my dear friends. And after that, let us go for log 5. Let's go and calculate log 5. You have to remember only the values of log 2 and log 3. Log 2 is easy. Okay, 0.3. That's it. But log 3 you have to remember this extra. That is 771. It's 0.4. But that extra is 771, that is 0.0771. Okay, cool. Let's go for log 5. Log 5 is equal to, my dear friends, you should remember the base is 10 here. I am not mentioning the base. So log 5, you have to tell me what is this all about. Remember this second expression, log, let us suppose we have here log 5, a upon b we have, log a upon b. That's equal to log a minus log b. So please remember this second expression. Log a upon b is equal to log a minus log b. So let us write it as log 5 as 10 upon 2. So my dear friends, log 5 is 10 upon 2. So this is your expression now for this. That is log a upon b. That is log a minus log b. So log a minus log b. So let's use it for this. So it will become log a. What is a? 10. Minus log b will be log 2. Everybody knows that log 10. Everybody is aware. Log 10 is equal to 1. Easy to remember. Log 10 is equal to 1. Look here. Log 1 is equal to 0 and log 10 is equal to 1. You should already know. Log 10 is equal to 1. So here I will write on 1 minus log 2 is how much? Log 2 is, already you are knowing 0. Come on, 0.3010 is the value. So finally you will be getting here, if you subtract this one from 1, you will be getting 0.699. Okay? So 0.699 is the log 5 value, my dear friends. I hope you have understood this expression as well. So let us go further and calculate for now log 6. So what will be log 6 all about, my dear friends? Log 6 is equal to, base will be 10 only. Log 6 is equal to log, let us suppose 2 into 3. Yes? 2 into 3 is 6. Now what is another expression you should remember? This was the exponential one, this was the division term, and now multiplication term I am using here. I will use here a into b. Log a into b is equal to log a plus log b. Log a into b is equal to log a plus log b. So this will be my term here. Like log a into b is equal to log a plus log b. So this expression will be used here. So let's use this expression. So I will use log a. Who is a? 2. Who is b? 3. So log a plus log b. So this is a and this is b. Now you are already aware about log 2, that is 0.3010. I have already written this thing. And log 3 also you are aware, 0.4771. So that is my expression, my dear friends. So let us simplify this particular thing. 0.3010 you have and 0.4771 you have. You have here 187 and here you have what? 7. 0.7781. 0.7781 is the value for log 6. I hope you have understood, my dear friends. And I also hope that you have remembered these expressions. Log a to the power b is that b log a by b, or a upon b is log a minus log b. And when it's a multiplication, log a into b is what? Log a plus log b, my dear friends. Let us go for now log 7. This log 7 you have to remember, just like log 2 and 3. Log 7 you remember, my dear friends. Log 7 is equal to 0.8450. So 0.8450 is the value of log 7. So let us go for log 8. So if you take on log 8, log 8 is equal to, my dear friends, log 2 to the power 3. That is 2 into 2 into 2. That is 8. So it will become exactly like the first expression, that is exponential form, log a to the power b. It will become exactly like this. So this expression is our log a to the power b, that is b log a. That is our expression. So let us do it. Take this 3 down here, 3 log 2. That is 3 into log 2 is how much, my dear friends? We are knowing about this. That is 0.3010. So what is the value here? 0309. That is 0.9030 is the value here. So that is log 8. I hope you have understood. Now let us go for log 9. Okay. What is log 9 equal to? That will be log 3 square. That is 3 into 3 is what? 9. So exactly the same thing it will follow. It will follow the same pattern. What is that? Log a to the power b. That is b log a. It will follow that pattern. Let's take on here. Take this here. 2 log 3. That is 2 into log 3 we are already knowing. Log 3 is 0.4771. We are aware about this thing. So let us just take it as 2, 14. It will become 15, 8 and it will become 9. So 0.9542. So 0.9542 is the value of log 9. And finally you have log 10. And obviously log 10 is equal to 1. So log 10 is equal to 1. Log 10 is equal to 1. So my dear friends, you have learned how to find out the log from 1 to 10. Okay, by this method. And the only thing which you have to remember is this thing. That is log 3 you have to remember, that is 0.4771. And you have to remember log 7 which is equal to 0.8450. These only two things you have to remember. Others you can calculate by using, you know what? These expressions, exponential and division term and the multiplication. You can easily find out the logs, my dear friends. Okay. So I hope you have understood this particular thing. Please make note of this. Now dear friends, let us do one or two problems here. Have a look. Let us suppose if you have to find out log 25. Okay. You can just simplify it like this. You can write down it as log 5 square. That is 5 into 5 is 25. And it will become our expression like log a to the power b. That is b log a, my dear friends. Correct? This expression. So I will get here as take it down to be 2 log 5. Okay. And you are aware about the value of log 5, my dear friends. Yes. So how to calculate that log 5 value is basically it will be 10 to the 10 divided by 2. And 10 log 10 is equal to 1. And 2 is 0.3010 and I was getting 0.699 the value. So it will become finally the expression 2 into 0.699. So what is the final thing here? It will be 18, 19, okay, 13. So it will become 1.398. So this is how you can find out the log 25, my dear friends. Now somebody among you may be thinking, like if we have an expression log 29 I want to find out, let us suppose. Okay. So log 29, how can we find out, my dear friends? The value of log 29 will be between, okay? In competitive exams actually, what happens? Approximations are being done because the 4 options will be given. So you should know the log related to what? Log 28 and log 30. If you are knowing these two, log 28 and log 30. What will be log 28, my dear friends? Log 28 will be how much? If I talk about here 7 into 4. So 7 into 4, it will become like what? Log A into B. So you can write it like this. Log A plus log B. And you are knowing the value of log 7 and log 4, so you can easily calculate this thing. Okay. Now log 30, you can mention it as, let us suppose, have a look here, 10 into 3. Okay. So obviously it will be again log A into B. And when it's log A into B, we know that log A into B is what? Log A plus log B. And we know the value of log 10, that is 1 plus log 3, that is 0.4771. So obviously, whatever the value you are getting here and here, the value of that log 29 will be between them, my dear friends. So whatever the value you get here and here. So in competitive exams, you can go for the approximations. But mostly, yes, the time is limited in the competitive exams. So what they do, they give you those numbers especially which are even numbers and which you can easily, or which do have a square or which do have a cube, so that you can easily find out the log, because time is very much limited. But even if sometimes if such things do come, then you can take the approximation, because 4 options will be given and you can easily reach to the conclusion right out there, my dear friends. Please make note of this. Dear friends, now look here. If I have log Kc is equal to, let us suppose, 20. Log Kc is equal to 20. And I want to just simplify this expression. I know that this log is a common log. Its base will be 10. So obviously base you have to take here. Okay. So I will write down, if log Kc is equal to 20, then my dear friends, 10 to the power 20, 10 to the power 20 is equal to Kc. Now I got the value of Kc. So how much is Kc equal to? Kc is equal to 10 to the power 20. And now you learn in this chapter what is the meaning of Kc. This is not required here, but you remember it's an equilibrium constant. So when you have log Kc is equal to 20, it's already given. So we want to find out Kc value. Log Kc is 20, but Kc, equilibrium constant value, is 10 to the power 20, my dear friends. I hope you have understood, dear friends. Now we will go for, after this, regarding antilogs. Okay, let's write down now antilog functions here. Antilog functions. Please remember this. Okay, have a look here. Let us suppose if I have antilog. Okay, now you have to decide. For antilog also you can have a base 10, or for antilog also you can have a base e. Yes. So for antilog functions also you can have a base 10 or you can have a base e, my dear friends. So let us simplify these things actually if we have an expression with us. Please try to understand. Antilog, let's suppose I want to find out antilog of x. And let us suppose it's given that antilog of x is equal to y. What is the base here? 10. Previous time when it was log, you can see here, if it is given as log x is equal to y, and what is the base here? 10. I was taking this base 10 and raised power y. So I was doing 10 raised power y is equal to x. But in antilogs, it is not like that. Okay? It is obviously opposite of that. Yes? Log and antilog are two opposite things, two reverse or inverse things. Now, when it was a logarithm, we were taking base 10 here, raised power y is equal to x. But here it will not be like this. It will be 10 raised power x only. That means this x will come as a power of 10. So 10 to the power x is equal to y, my dear friends. So see the difference here. Base 10 power was y is equal to x. But in antilogs, exactly opposite. 10 to the power x is equal to y. Now look here, my dear friends. Antilog, what is the base here? E, let us suppose. And let us write down here the same thing, x and y. You can use a and b also, it's your choice. Antilog of x is equal to y, let us suppose. Okay? Then what will be here? It should be, if it is the log with base e, then it will be e to the power y is equal to x. But it's again antilog. In antilog you have e to the power x is equal to y, my dear friends. I hope you have understood this thing. So in order to avoid the confusion, let me compare them, my dear friends, here so that you can remember it. Have a look here. Let us suppose I have log p is equal to q. Correct? What is the base here? 10. So I will take this base 10 raised power q is equal to p. This is about log. But when I compare it with antilog, try to understand. Antilog, what is the base of antilog here? Let us suppose 10. And let me write down the same expression. P is equal to q. Okay? So here we have to take on the base 10 and q will not come as a power. Now p will come as a power. So 10 to the power p is equal to q, my dear friends. And same is the case with respect to e. Let us suppose if I have log to the base e, okay, we have here, my dear friend, let us suppose a is equal to b. It will become e to the power b is equal to a. But if it is the antilog to the base with base e, okay, and same thing I will write, a is equal to b. It's not necessary that this a and b will be similar to this. I'm just giving an expression, my dear friends. Here you take on the base e, b will not come as a power, a will come as a power. E to the power a is equal to b. So that is the difference between log and antilog, my dear friends. Please remember this particular expression and we'll go further. Let me just make it a little easier for you here. Let us suppose now you got to know about antilog. Okay? Let us suppose we are finding out, we have a value here something, let's suppose we take on it as 0 or we can take it as 1, it's our choice, okay. Let's take on antilog of 0 is equal to 1. You can take any number, it's your choice. So I am finding out antilog of 0. When nothing is mentioned here, if they mention here e, then understand that it is basically the Euler's base, yes. But if they don't mention anything, then understand that 10 is there, common, okay? Now tell me, is it 10 to the power 1 equal to 0 in antilog or 10 to the power 0 is equal to 1? So obviously 10 to the power 0 is equal to 1. So this base will be 10, 10 raised power 0 is equal to 1. So I will write down if antilog of 0 is equal to 1, then 10 to the power 0 is equal to 1, my dear friends. This is the antilog expression, please remember. Usually we are converting antilog with base e to the antilog with base 10 only. That we know. So obviously please remember. And after this I will teach you certain values which are quite important for your examination point of view. Please remember this thing. Dear friends, let's take on now antilog values from 0 to 1. So let us start with the first. Antilog of 0 or antilog 0 is equal to 1. So how come it's equal to 1? Because the base of antilog is here 10. When nothing is mentioned, it's 10 only. So it will be 10 to the power 0, my dear friends. 10 to the power 0. 10 to the power 0 is equal to 1. And antilog of 0.1. What is the base here? 10. So it will be 10 to the power 0.1. Okay. And obviously here it will become 10 to the power 0.2. This will become 10.3 here, then it will become 10 raised power 0.4, and here 10 is the base, it will become 10 raised power 0.5, and finally this will become 10 raised power 0.6, 10 raised power 0.7, 10 raised power 0.8, 10 raised power 0.9, and 10 raised power 10 raised power 1. So my dear friends, finally, how to remember the values of antilog, like from 0 to 1. It's a very simple thing, my dear friends. Okay. First of all, when we talk of antilog here, if we take antilog, let us suppose antilog of 0.6 if I take, correct? And what is the base? You should remember the base is 10. So this expression is actually 10 raised power 0.6, remember that. And 10 raised power 0.6 is approximately equal to 4. Yes. Now, how to remember them, my dear friends? Let us take the approximation. It is 1 only, so no problem. It is 1.258. So it can be approximately taken to 1.26. Okay. And 1.58 can be taken approximately to 1.6. And 1.9 can be approximately equal to 2. And this is your 2.5 only. This is 3 only. And now this is 3.9 and approximate is 4. This is 5. And this value is 6.3. And this value is 7.9. So approximate is 8. So let me encircle these numbers which I need. In place of 6.3 you can take 6 also, does not matter. Okay. So have a look here, 3, 2.5, 2, 1.6, 1.26 and 1. So let me write down those numbers now. It's 1, then we have 1.26, then we have 1.6, then we have 2, then we have 2.5, then we have 3, and after 3 we have obviously 4, and after 4, 5, then 6, take it as 6, does not matter, take it as 6. Okay. Then you have 8 and 10. Now practice it, my dear friends. Now you can practice these values, my dear friends. So it is 1, practice with me, it's 1, 1.26, 1.6, 2, 2.5, 3, 4, then after 4 you have 5, then you have 6, 8 and 10. If you practice it 2-3 times, obviously it will come into your mind. Actually these are the Antilog values from 0 to 1. Okay. So obviously let us practice it once again. 1, 1.26, 1.6, 2, 2.5, 3, 4, 5, 6, 8 and 10. So I hope you have understood these things or not. Please make note of this. Let's solve one problem with respect to these antilog values, my dear friends. Let us suppose you have log Kc is equal to 30.9, my dear friends. Okay? And you want to simplify this particular problem. So how can you simplify this particular problem? Okay? Let's understand this thing. Okay? You can directly take on here 10 as a base. Okay? So if you are going for logarithm, then it will be 10 to the power. It will be then 10 to the power 30.9. This 10 to the power 30.9 is equal to Kc. So my dear friends, Kc is equal to 10 to the power 30.9. Now you have to further simplify it, my dear friends. How to simplify it? Kc is equal to 10 to the power 30, okay, into 10 to the power 0.9. So my dear friends, when bases are same, powers are added. So obviously 30 plus 0.9 will be what? 30.9. So I can simplify it like this. And what is the value of 10 to the power 0.9? Have a look here. What is the value of 10 to the power 0.9? You already remembered it's equal to 8. Or 7.9, and you can write down 8. 8 is the value. So here we have 10 to the power 30 into 8. So I can write down 8 into 10 to the power 30. So that is the Kc value. This is simply by using we are just finding out Kc value, that is log Kc was equal to 30.9. So then I applied that expression. Okay, what was that? Base raised power 30.9, that is 10 raised power 30.9 will be equal to Kc. So I solved this problem. Now we have to actually use antilog to get the same value. I can solve it through antilog also. Have a look. How to solve it through antilog? Try to understand and remember this value. 8 into 10 raised power 30. Remember this value. I will take the same expression and solve it through antilog. Let us suppose your expression was log Kc is equal to 30.9. And how to solve it by using antilog? Okay, let's call it as equation 1. Apply antilog on both sides. On both sides of equation 1. So let us apply antilog here. So antilog log Kc is equal to antilog of 30.9, my dear friends. Antilog and log will cancel, my dear friends. And remember always this antilog has base 10. So what is the remaining here? Kc is the remaining here. Kc is equal to antilog of 30.9. What is the base? 10. Remember that? And everybody knows in case of antilogs, you have to take on this base. So Kc is equal to 10 raised power 30.9. 30.9. Have a look here. Antilog of 0.6. What is the base here? 10. So it will be 10 raised power 0.6. So 10 raised power 0.6 is equal to this. So obviously if you have an antilog of 30.9, what is the base? Base is 10. So 10 to the power 30.9. And 10 to the power 30.9 will be equal to 10 to the power 30 into 10 to the power 0.9. And 10 to the power 0.9, we are already aware, that's equal to 8. So finally we will get here 10 to the power 30 into 8. Or we can write down 8 into 10 raised power 30. So exactly we got the same answer when I used the log function, and now I am using the antilog function. So our answer is same, 8 into 10 raised power 30. There are many more things which you will learn in this particular chapter. But you have to wait. I hope you have gotten the idea today about log and antilog. But once you apply these log antilog values, okay, in the chapters related to chemistry like chemical kinetics, electrochemistry, yes, thermodynamics and equilibrium chapter, then more you practice, more easy it will become, my dear friends. Let me simplify it in a very simple way here. Let us suppose if I have pH is equal to negative log of 10 raised power minus 3. This expression is equal to log a to the power b, that is b log a. So this expression what I have here. So it will become equal to pH is equal to, take this minus outside here. Then this log a to the power b will become minus 3 log 10. This 3 will come down. So minus minus is plus. So 3 is here and log 10 is equal to 1. So obviously it will become 3. So 3 is the answer. So easily you can do it, my dear friends. Once we start applying it in the chapter, easy it is right out there. So I hope you have understood many things today. Take care of yourself and remember those values, practice them 2-3 times and obviously they will go into your head easily. Okay, have a great time. Thank you. Yo-yo.